PipeSim is classified as a flow assurance steady state simulator, okay, or multi-phase fluid flow simulator, in which the user can, or the engineer can use the software to model the fluid flow in the wells and the pipelines with the main objective, which is flow assurance. And this term is very important because in our industry, most of the fields around the world, maybe except maybe exception in the US, where there are a lot of fields there that are actually producing very low flow rate, in which they can actually combine the oil in trucks or storage, or store it on the surface. But in everywhere, even in the US, the main transport means for oil and gas, and of course water, is pipelines. And it's very important that we make sure that the oil or the hydrocarbon will flow in these pipelines successfully without any problem. Okay, and that's why the term flow assurance. We need to assure the flow. Okay, so PipeSim falls under the classification of steady state multi-phase flow simulator. In Schlumberger, we have another product called Olga, which is the transient flow simulator. The main difference between steady state simulator, fluid flow simulator, and transient flow simulator is the fact that, as the name states, it is steady state, meaning we don't take, in PipeSim, we don't take into consideration the disturbance time. And that's why there is no, let's say, time concept in PipeSim where it shows you the impact of, let's say, opening a well quickly, closing the well quickly, what are the disturbances in the system. This is mainly used by Olga. Okay, in PipeSim, it is used to model the steady state flowing conditions in the wells and the pipelines. You can use it in the design, okay, the design phase of your field, where you can design well tubulars and completions. And also you can design pipelines and equipments, such as, surface boosters. You can also design the best pipeline diameter, etc. Once your field is installed, your wells are drilled and they are producing. Now we go to the operations phase. So you need to manage liquid slugs and surges, for example, or you need to optimize production. When we say optimize production, this is really a very wide term, but in a sense, you need to maximize your hydrocarbon production with the lowest cost, okay, and to achieve it on the long term. So that's why when we go to the production optimization, this is, I think, what we are going to talk about in 2 weeks from now, where we are going to look into how we can optimize production, how we can maximize production at the lowest cost, and increase our recovery from the reservoir. And also we need to look into wells and pipeline integrity. We need to manage erosion and corrosion and avoid blockage. This blockage could be caused by solid precipitations, such as scale or hydrate, for that matter. I don't know if you heard what happened in the US about maybe 2-3 months ago, where the temperature in Houston, Texas, dropped significantly below 0 degrees, of course, Celsius. And this resulted in forming a lot of hydrates in the pipelines. So the pipelines were blocked to transport fuel to the power plants. And then this resulted in a major power shutdown in Houston, Texas, right? So this is just a simple example of how can the hydrocarbon conditions block the flow. And that's why, again, the term flow assurance, okay? So with this introduction, let's just also take a look into the pressure concept in any production system, okay? So this is a cross section of a production system. As you can see, and of course we all know that the production starts from the reservoir, okay? The hydrocarbon, whether it's oil or gas, will flow in the porous media until it reaches the well, and then it will flow inside the tubing. Maybe we have artificial lift or not. And then we go to the surface facilities, we reach to the separator, and then we either take the gas, the oil, and maybe the water to inject it back or to basically use it somewhere else, okay? So for that, let me see here. For that, you know, we need to make sure that if we need really to consider the flow assurance for a well only, the system and let's say the simulator needs to consider all the pressure boundaries along the flow path. All right, that's why we will need to look into the pressure drop in the reservoir, what we call it reservoir drawdown, the pressure drop along the completion, and the pressure drop in the tubing, pressure drop if you have subsurface safety valve, pressure drop in the wellhead choke, in the flow lines, if we have risers, separators, etc., etc. So all that the system need to take, you know, consideration of. All right. Number one, the flow in the porous media, how we are going to model the inflow from the reservoir to the completion. How can we model the artificial lift, whether it's electric submersible pump or gas lift or any other artificial lift means? We also need to model all the flow regimes. As you know, when we have multi-phase flow, we can have, you know, all kinds of, it could be bubble flow, it could be, you know, annular flow, etc., etc. So all these, that's, as you can see here, it's not an easy system. It's a complex system. And because we have hydrocarbon, we have the multi-phase that can change along the flow path. And that's why you need really a powerful tool, powerful simulator to model this multi-phase flow. So if we look into the concept of what we call the nodal analysis, all right, in which we look into the flowing bottom hole pressure in the well, right? And then we see how the flowing bottom hole pressure will change by changing the flow rate, okay? For example, if there is no production, so let's assume that on the x-axis is the flow rate, the y-axis is the flowing bottom hole pressure, okay? So when the production is zero, basically we're starting at this point, the flowing bottom hole pressure will equal the reservoir pressure because there is no drawdown, correct? Now, as we start production, the last pressure that the flowing bottom hole pressure will see is the separator pressure, okay? And now this is the IPR. This is the inflow performance relationship that will take into consideration the drawdown from the reservoir to the well, all right? And then also we have the outflow that represents the pressure drop, the relationship between the flowing bottom hole pressure and the flow rate, but considering the pressure from the separator. This is what we call the inflow and outflow, or IPR and VLP, vertical lift performance. The intersection between the two curves will define the operating condition at this point. Okay. So PIpeSim has this concept in addition to other concepts to model the production in the well. So for example, if we make production stimulation, where we can reduce the pressure drop or the drawdown in the completion via hydraulic fracturing, for example, this IPR curve will go up and then we will have the intersection between the inflow and the outflow moving to the right, then we have more production, right? Similarly, if we can install an ESP, we can bring the outflow curve down, okay? And then also we can bring the intersection further to the right so that we can increase the production, okay? So this is the concept of nodal analysis, right? Now, we need also to consider not only the pressure drop, but also the temperature drop, okay? And this is important because, as you know, the fluid hydrocarbon properties such as viscosity, density, Reynolds number, all these parameters are also affected by the temperatures, okay? So we will need to take into consideration the temperature in the delta P in the tubing, delta P across all the fittings, all right? And then we need to consider the convection heat transfer, the conduction heat transfer, Joule-Thomson effect, and so on and so on. All that is important. And this is now, both when we consider the pressure and the temperature, we can, the simulator can follow the pressure temperature profile of the fluid, all right? And then we can define whether we could have scale, all right? We could have hydrate, etc., etc. And this is how you need to handle your production system to avoid these blockage conditions. So PIpeSim can be used, as I said before, on the early field development for well design, pipeline design, network design, all right? And also it can be, and of course this will take years, right, to put in place. And then once you have the production operations, this can go to days and hours, and we can do well optimization, pipeline optimization, and network optimization, okay? So all that can be used by a simulator such as PIpeSim. PIpeSim has an advanced three-phase mechanistic flow model called Olga-S, Olga steady state. It's the industry standard multi-phase flow model with more than 150 million of research investment in Olga since the 80s, all right? So Olga is, as I said, is our transient, is Schlumberger transient flow simulator. And, it has been accumulating research and development with, Sintef, which is a research center in Norway, and and IFE also is it's a research institute in Norway for flow technology, okay? PIpeSim is not new. PIpeSim has been there since the 80s, and in 1984, PIpeSim was firstly released, and it was only keyword driven. Keyword meaning the user has to go and type the description of the pipes, description of the fluid, etc. Right? And then in 1993, it was the first graphical user interface, where it was 16-bit at the time, right? And then in 2001, we have the second generation graphical user interface, and it was 32-bit. And then in 2013, we have the new generation. And this is the same generation that we have today. And it's a continuous development. We have a new release in this year, targeted in fourth quarter, which is 2021, okay? For the heat transfer, PIpeSim has complete energy equations. It has rigorous thermodynamics. It can model conduction and convection. And it will consider the flow regimes in calculating the heat transfer. It has rigorous buried pipe model developed by Schlumberger. And it has heat transfer in wellbore using Ramey model. This is added into the new release that's going to be available in 2021.1 release. And it considers Joule-Thomson effects across fittings, which is very important. PIpeSim also is very powerful in fluid characterization. It has rigorous compositional models using multi-flash. Multi-flash is you know, a third-party fluid characterization package by KBC. It is tightly integrated with PIpeSim. We have E300, which it's another fluid characterization package. And also we have GERG, which is an advanced gas equation of state. We have thermodynamics prediction of asphaltene, wax, hydrate, and scale, okay? All these are major problems of solid deposition inside pipeline walls. It's worth mentioning that corrosion and scaling accounts for 19% of well integrity failures globally. This can be translated into about $200 million a day of revenue loss, and this is really significant. PIpeSim network simulation. It's really, many people who are not in this field don't realize that modeling production networks is very complex, and the reason for that is when the wells are connected, with time there are strong wells, there are new wells that are drilled, all right, and added to the system, and they will be competing with the weak wells. These weak wells will have lower pressure when the production reaches the surface, and then it may not be able to compete with the strong wells. This could cause what we call back pressure, then the wells cannot flow. So it can be as simple as, if you add just 2 or 3 wells to your production system, you might lose 5 or 6 wells that are already in production, and this is due to the you know, shared pressure that propagates along the pipeline network. So it's really important that pipeline network is modeled, you know, comprehensively, and with a strong numerical solver such as PIpeSim. Why we need the network simulation? Because you will need it in the beginning in the field development. If you have a new field, you will need to know, for example, should I plan for gas lift or ESP for the wells? So even the wells themselves, you need to know what is the tubing size that you need to use for the well. Are you going to drill a horizontal well or a vertical completion? Do you have multi stages, or do you have multi zones in the reservoir? And if I drill these multi zones and make them, all of them produce, how would that affect the surface production? All these questions, when it comes to well placement and well drilling, are very essential in the planning or the field development stage. You need also to see whether, do I need, if it's a subsea, do I need to install a subsea multi-phase booster, for example? Do I need, you know, what kind of pipeline size do I use? This is very important, because if you put small pipeline size, right, this will of course result in blockage, because there will be a lot of pressure drop due to friction. But if you increase the pipeline size more than you need, then the fluid velocity in the pipeline will become less, and then there will be segregation between fluids. You will find that the water will start to settle at the bottom, right? And this will cause major problems, because it will result in corrosion, and then this will result in you know, leak into the pipeline. This is a major pipeline integrity issue. So designing the right size for your pipeline is very, very important. And the challenge is, pipelines are not something cheap, right? Once you place them, they will stay there for decades, right? You go to many countries who have been producing oil for years. You could easily find pipelines that are there for 40 years and they are still used, okay? So it's very important that you really size your pipelines properly, okay? When do I drill new wells, okay? And what size of surface pump should I use in order to export the let's say the gas or the oil to my sales point? And how can I inject? How can I design the injection wells if I take the separated water and then re-inject it for pressure maintenance? As you can see here, all these questions need to be answered when you are doing the field development. Okay. and then will hydrate form, etc., etc. Now, after I have my field and the field is in production, then what will happen 10 years later? Okay, you have a mature field now that has been in production for many years. Now, how can you use the network simulation here? Then you need to ask your questions such as, can I meet my contractual delivery next month? Now, the challenges are different, okay? Should I switch my multi-phase boosters from parallel to series to, let's say, to increase the production flow rate, for example? How much methanol should I inject to reduce the hydrate temperature, for example? When do I abandon these wells? There are many wells now that are they start to produce less and they are fluctuating. Do I abandon them or not? Okay. How much gas lift should I inject? Should I stimulate this well, etc., etc.? How to prevent severe riser slugging, and so on and so on. So all these questions need also to be taken into consideration once the field is mature. Okay. PIpeSim can be also used for production optimization or network optimization. Okay. You need to maximize your production at the lowest cost. What do I mean by that? In many mature fields, you start to need, and even sometimes in new fields, you might need some form of artificial lift, meaning either electric submersible pump or gas lift or PCP, etc. Right? Now the question is, how much? What is the size of the pump? And when I let's say I have the system is in place, how can I reduce the power consumption to maximize my production? And how can I reduce, for example, the gas lift rate to maximize my production? This is an important question, and especially, as you know, the oil and gas industry has been really fragile in the past months. So cost is very important, all right, for any operator. How can I honor facility handling capacity? For example, with time, your water production start to increase. If you have, let's say, water layer under your oil, for example, then as the water increases, you might hit a limit of your facility, separation facility. So you might need to say, okay, now how can I reduce the production from the wells that are cutting water or that are producing high water cut without actually disturbing my system? So it's really a challenge, because it's really a back and forth and trial and error, because the moment you change something, another well will be affected. And that's why you need what we call the network optimization. How can I increase my reservoir recovery? What do you mean by reservoir recovery? Meaning you will need, for example, to delay water production, or maximize your production from the reservoir. If you have gas coning, if you have water coning, for example, then you need to delay all that by restricting the production. Or sometimes you need, even if the well has potential to produce more, you need to limit it in a certain amount. Suppose that the well can produce 5,000 barrels per day. But if you leave it like that, then the well will start to invite water quickly, and then you will lose your well faster, although you still have a lot of hydrocarbon in the reservoir. So it's a possibility that you might reduce the production, limit the production to say 2,000, for example, and you take much longer time of plateau because you are delaying actually the water production. How can I maintain asset integrity? And when we say asset integrity, we include pipelines, we include wells, and we include even the pumps. You need to operate the pumps in certain frequency so that it doesn't operate under or outside the operating envelopes, for example. So all these questions are interrelated. So you need an optimizer, a mathematical optimizer, to tell you how you set your production conditions across all your wells. And this is what PipeSim can do for you. And this is, I like this feature. PipeSim is integrated with graphical information systems, GIS, right? And this is just a screenshot of a model, of a network model that, as you can see here, we can see the, once we run the network simulation, you can look into the results gradient along the pipelines. You have this color-coded scale. And this applies to all the results in the network: pressure, temperature, velocity, etc., etc. Okay. So you can visualize color-coded results. You can capture flow line profiles easily. This is very a nice feature. Okay. Many people don't know that in most graphical or geographical information systems services, even like Google Maps, it's not only 2D. Any point on the map has also the elevation, but we don't know that, right? So what we do in PipeSim, we have an agreement with a third party, it's Esri basically, where and other services as well. You can place your 2D pipeline profile on your map. And with a click of a button, the pipeline elevation points will be captured automatically from the internet, right? And this is very useful because in order for the simulator to understand how the pressure is changing, how the velocity is changing, you need really to capture the pipeline topography, pipeline profile changes. And this is possible, of course, if you have it handy, if you have it in Excel, but in many cases it's very complex and it could be not available for you. With that, you can easily draw your pipeline profile along your 2D map. With a click of a button, the pipeline profiles can be captured easily from the GIS service. Okay. You can also build pipeline network automatically. What you can see here, for example, and this is in many big oil and gas companies, they use what is called GIS shape files. Shape files are nothing but a layer of the drawings of the pipelines. So you can import this shape layer or shape file, lay it on top of your GIS area, and then PipeSim can generate your pipeline network automatically using this GIS shapefile. You can also design pipelines considering geospatial limitations. And this is very important. For example, if I have a mountain here, if I have a lake here, all right, and then you'd like to drill a well in this area, but then you don't know how you're going to place your pipeline. So this is very useful because you can easily digitize your pipeline 2D and then run simulation, okay, even before you place your pipeline. This is very useful and very handy for all operating companies. PipeSim also has what we call extensibility and automation using Python toolkit, right? So for many of the fresh graduates and maybe even students in the universities, we all know that Python now is the new programming language that really every engineer must learn. And my advice to everyone in this call here, if you want a better career, right, data science and Python is a very I would say important learning essential for you. You need to learn data science. You need to learn Python, even if you are a normal petroleum engineer. When you add this programming skill to your profile, when you add especially Python, you can do miracles with it, right? Because it's all about now. It's all about data. It's all about automation, etc. And we offer this capability in PipeSim. What we call it, Python toolkit. This empowers users with workflow automation. You can build will and network models without using the UI, without using the user interface. With just writing, Python scripts, you will be able to build the model without opening the PipeSim UI automatically. You can literally build hundreds of wills with a click of a button if you write the right script, okay? Not only that, you can update your models with operational and testing data. If you have models and if you have an existing network model, for example, and then you have a workflow where you have a digital oil field where you have measurements, real-time measurements that are coming every hour, every day. And then you need to run the simulation and get the results back and create dashboards, for example. This can be done using Python Toolkit, PipeSim Python Toolkit, because you can use PipeSim as an engine, as a back-end engine, where you take the data, send it to tools, run the models, get the results back, and display it in a dashboard. Okay. You can run batch simulations and analyze the results. You don't, if you want to run, let's say, 100 combinations or 100 sensitivities, you can update the pressures, update the temperatures, update let's say the gas oil ratios, etc., and then get the results back. You can do forecasting scenarios using that. It can facilitate using PipeSim as an engine, as a back-end calculator. Okay. It replaces OpenLink API in PipeSim Classic. So I'm probably sure that majority of you don't know that, but PipeSim in the past used to have this capability for extensibility and automation using a previous technology called OpenLink, and this was in PipeSim Classic that stopped in 2012. Python is the development language for engineers. So again, I will emphasize this again. All petroleum engineers today need to learn Python. This is very important. And it's simple to use. There are a lot of free tutorials. There are a lot of free training courses. And I will probably ask Nikhil and Chata to maybe they already have arranged such course. You need to really offer free courses for Python programming. Okay, it can be embedded in Excel, where you can automate, the data exchange between Excel and PipeSim, and you can build your own interface. So this is Excel, for example. You can build your own interface that will run PipeSim in the background and get the results back into Excel. And you can impress your boss and your colleagues with that. Okay. PipeSim is available in Delphi environment. So I'm not sure if you're attending this session while you are already employed in a company, or you are still a student, or you are a new graduate, fresh graduate. PipeSim can be installed in the standalone PC as normal, or it can be accessed through the internet. So in Schlumberger, we have what we call Delphi environment. Delphi is our cloud-based environment, where with using a URL and subscription, you will be able to go to all the technologies that Schlumberger software have today, and one of them is PipeSim. So you don't really need, or you don't have to install PipeSim in your machine. You can actually run it through the internet. And what happens in the background is that, because PipeSim is a Windows machine, we create a virtual machine for you in the cloud, all right? And then you will be able to run all the functionalities, all right, using this URL. Of course, you will need a bit of fast or high performance internet, high-speed internet to do that. Okay, now let me show you a quick example, a quick video on how I update completion properties, okay, using Python, right? So now this is a very simple Python script, okay, in which I have a model name. So this is the model name. This is the path. I call it test. And then I have a save name. It's called test new. Okay. So this is the test. This is the model. Okay. What I'm going to do is that I'm going to say that, and I'm importing here an object called a library called model. Now I will be defining model1 equals model dot open the model name. So it will open that in the background. And then I'm going to set a value, right? I'm going to set the completion reservoir pressure to become 3,210. And I'm also going to set the temperature, and I'm also going to change the liquid PI. All that will happen without actually opening the user interface, the model, the PipeSim user interface. Okay, so let's do this. I hope that with the the internet speed that you have, you'll be able to view the I mean, the bandwidth is good enough for you to see.